All right, so on section 8.3, we're talking about logarithms and laws of logarithms, and so I want to go over a few examples with you. Well, one example from the lesson, and then a few of your homework questions. So the reason why I wanted to outline this one here is a couple things. We're going to get practice at using our laws to create one single logarithm given this, but also this part here, state the restrictions on the variable. So it is very important for us still to remember through all of this that we cannot take the log of a negative value. So what we're going to find is that sometimes that value is just x, sometimes it's an expression. So x could itself be negative, but the expression, or whatever we're taking the log of, that thing cannot be negative. So yeah, there's restrictions. I think this one's just going to boil down to just an x, but let's keep going with this. So what we can do here is we can understand that we have logs of, they all have the same base of 7, so that's great. We're adding these logs here, okay, and we're subtracting this thing over here. Now this thing over here is what I want to focus on, the last one. I would like to write that, instead of 5 log x base 7 over 2, let's write that as 5 over 2 times log of x base 7. Now why is that important? Well, because you can see that this is a coefficient in front, right? So this actually could be written as an exponent on the x, which is going to be important. So I'm going to do that actually right now. I'm going to put this number here, that's going to be gone from there, and that's going to go up to be an exponent on the x. So this is important for you to note. This right here, okay, can be written as this right here. All right, very important. So now that we've got that out of the way here, let's take a look at this now. Okay, so we've got these two things are added together and then divided by, or subtracted by this. So I can write this as log of x squared times x, because we're adding the logarithm, so a single logarithm would make this a multiplication. And then we still have this subtracted because I haven't dealt with this yet. So because now we have a subtraction of logarithms with the same base, then we can divide this divided by this. So watch how this works here. This is actually going to be log of x cubed divided by log of 5 over 2. X to the 5 over 2. All right, so we're getting somewhere now. We're getting somewhere. So what do you do with this? Well, hopefully you remember that when you divide terms that have the same variable or the same base, you can subtract the exponents. So that still holds true. So inside this logarithm, we can simplify it this way. So this is actually going to be log of x to the 3 minus 5 over 2. Or log of x to the, now how do we subtract that? Well, 3 is actually 6 over 2. So 6 minus 5 is 1 over 2. This is all base 7. Okay. All right, so that's awesome. Now what we could do is we could, if you want, a single, each expression as a single logarithm. So this is fine. You can leave it like this. But you could also understand that you could write this like this. Sorry, log of just regular old x base 7. So you could have this as your most simplified version. Either one of these are okay. Now, it is important to note here, we're not quite done yet. We need to have restrictions for x, which, of course, this part right here cannot be negative. So x has to be positive. Can it be 0? No. Can't take the log of a negative. You can't take the log of 0 either, right? Because, let's say, 10 to what power will equal 0? Can't get to 0. You can only get to a really small number. So x has to be greater than 0, okay? Or x cannot be negative. Okay, any questions about that one? It's part of your answer there. All right, so here's number 3 from your homework assignment. I'm going to do 3B and C here for you. Again, write the expression as a single logarithm, so just lots more practice with this now, okay? And this is a very similar situation to the example we just did. Remember, this is like 1 over 2 times log of x, right? And that's going to be really handy because now I can put that 1 over 2 up as an exponent. I can also go ahead and write that as square root x. Wow, that's awesome. Okay, and that's pretty small now, crowded. Let me make that a bit bigger. Boop, there we go. All right, so you see how we got there? See how we got there? The 1/2 came up as an exponent. X to the 1/2 is root x. Okay, minus. Now I'm going to put this 2 as an exponent on the y, because that's one of my rules, one of my laws. Y squared, base 3. As a single logarithm, okay, so this is subtraction, which means I should be able to divide these. Now, these are different variables, right? There's an x, there's a y. So you can't simplify, like root x divided by y squared, you can't simplify that to one variable, but we can still show it as a division. So that's going to be root x, or x to the 1/2, whatever, divided by y squared. Okay, so just double check that. Minus, we're dividing, yeah. Single logarithm simplest form. Okay. Now whether you have that square root sign or a power to 1/2, doesn't matter. Okay. All right, so that looks good for B. I'm okay with that for B. And for C here, okay, so for C, we're going to do brackets first. BEDMAS says let's do some brackets first. This 2 can come up as a squared. What else? Okay, that 1/5 is going to be multiplied by what's inside here. So let's just do one step at a time. So log of x base 6 minus 1/5. How can I rewrite this in here? Well, that's going to be x. It's going to be log base 6 of x times y squared. xy squared. Okay, xy squared. And now, of course, we don't need the brackets there now because there's just one single term in there. And this 1/5, okay, this 1/5 can actually be an exponent on this whole thing. 1/5. Can't just pick and choose there. It's got to be the exponent on everything there. Okay. So this is a subtraction, so I'm going to write this as x divided by, I'm going to go x to the 1/5 times y to the, you see when you multiply, right? 1 times 1/5, 2 times 1/5, so that's 2/5. And this inside I can simplify. So this is going to be log of, what's 1 minus 1/5? That's going to be x to the 4/5 over y to the 2/5. Okay, that appears to be where we can stop. Let's just double check that. Okay, so the back of the book didn't simplify this quite as much. I think they had this as log of, they had x over 5th root of xy squared. That's where they left it, which is fine too, base 6. Okay, either way is good. Okay, I'm just going to give you some quick tips for number 7 because we need to kind of move on here today. So for number 7, decide whether each equation is true or false, justify your answer, and then assume cx and y are positive real numbers, c doesn't equal 1. Okay, so we look at these and you see that this satisfies, this is completely in line with the quotient law. Okay, the quotient law. So I think that would be an easy enough justification. Okay, you could input values in for x and y and c. This is product law. Okay, and I'm okay if you just say that, product law. This one here, okay, so this is power law. And some more justification might be required here because this is not just straight up from the textbook chart. You might want to say n times log of c base c equals n. And then log of c base c is 1, right? So then n equals n. If you did something like that, then that would show, hey, that is true. This one's interesting though, okay? Because here we have, this is sort of like the power rule, but this is the whole thing is to the power of n. So what you might want to do there is just plug some values in and see if that works. So for example, what is log of 100 and all of this to the power of 3 versus 3 times the log of 100. So is that the same, right? So you could get on your calculator, and the log of 100 is 2. 2 to the power of 3 is, well, I guess this is 8. We don't need our calculator. The log of 100 base 10 is 2, so this is 3 times 2. So this is not equal. All right, so D, not equal. Okay, that power rule is only when an n is an exponent for the x there. Okay, this is interesting too because I want to just share with you one more law that wasn't in our textbook. Okay, so this one is saying that if you put a negative sign in here, you have a 1 over x. You can take that negative sign off and just write this as an x over 1. It's kind of a reciprocal there. Okay, now again, we could test some values and see if that's true, which might be a good idea. So for e, let's do that real quick. Negative log of, let's say this is 1 over 10. 1 over 10, base 10. So what is that? That's equal to 10 to the power of what? That's negative 1. Well, what is log of 10? Well, that's clearly positive 1. Oh, negative 1. Oh, here we go. Negative 1. So they are equal. Okay. So that could be true. You might want to try some other ones and then make your statement there. But where is it? For this question here, and I actually won't do this one in this video here, but I want to highlight this logarithm base switch rule. Okay, this is not in your textbook. Found this online, but it'll be helpful for question number 20, especially. So if you have, let's say log of c base b, like they have, I'll just write this a little differently. 1 over log of b base c. So in order to switch these around, if you write it as a reciprocal, you can switch them around. See that? So c base b or b base c. So that one works. Okay, for sure. So if you notice here, log of 2 base p, okay, you could actually rewrite that as log of p base 2. And this one could be log of p base, log of q base 2. Yeah. And then, so this would be log of p divided by q base 2. And that's what we have. So here's your proof. And it's because of this change of base formula, base switch formula. Okay? All right, so there's a little bit of help with your homework from 8.3. And yeah, I hope that helped. And we're going to do 8.4 here next.